Good morning, friends. I hope you must have all studied the earlier topics which I have taught from this chapter. In the chapter electrochemistry, we started with the what do you mean by electrolytic cells? What do you mean by electrochemical cells? Electrolytic cells convert electrical energy into chemical energy. Electrochemical cells convert chemical energy into electrical energy. Then we talked about electrolytic cells. What will be the product of electrolysis of different electrolytes if we take them aqueous, the products are found to be different. If we take molten, the products are found to be different. If we take the electrodes made up of same metal, the products are found to be different. For example, electrolysis of copper sulfate using copper electrodes, or electrolysis of copper sulfate using inert electrodes. The last topic which I taught was about differences between electrolytic conductors and metallic conductors. There are very clear cut, at least 3 differences you should know between an electrolytic conductor and a metallic conductor. Okay, I hope the numericals of the chapter solutions, which I have solved, all the NCRT questions which I had given you as a homework, I have solved them and shown clicked the pics, and I have posted them in the group. I hope every one of you must have done them in their copy. Okay, now let's just start with the next topic. The next topic deals mainly with different types of conductivities. First one is specific conductivity, equivalent conductivity, molar conductivity, etc. Now we know that suppose we have a conductor. If I apply a voltage of V volts, Ohm's law, I'm talking about Ohm's law. If I apply a voltage of V volts across the conductor and pass a current of I amperes, we know that the resistance which will be shown by this conductor will be given by V by I, and that is equal to R. You know this is Ohm's law. You must have already studied this in physics. V by I is equal to R. This is the Ohm's law. If I have a conductor, and that conductor has if I apply a voltage of V volts across the conductor and pass a current of I amperes, that conductor will show certain resistance, and that resistance which will be shown by the conductor is given by V by I is equal to R. Resistance, you know the unit of resistance is ohms. Okay. Now we know that resistance is directly proportional to resistance का opposite क्या होगा? If I say resistance, the opposite of resistance is conductance, and that is denoted by G. That is denoted by a small g. If you can very clearly see, I have a conductor. If I apply a voltage of V volts passing a current of I amperes, the ohms, according to Ohm's law, the resistance R will be given by V by I, which is equal to resistance. Opposite of resistance is conductance, and that conductance is denoted by G. The unit of G will be ohm inverse. Unit of resistance is ohm. So unit of G, that is conductance, will be ohm inverse. Now further, if you pay attention towards what I am teaching, it is found that the resistance R is directly proportional to length of the conductor denoted by L, and inversely proportional to area of cross section denoted by A. Here L by A is called cell constant. L by A is called cell constant. तो जो resistance है किसी भी conductor की, that is directly proportional to the length of the conductor and inversely proportional to area of cross section. That proportionality sign I am removing, and when I remove the proportionality sign, I am putting a constant which is called rho. Rho is specific resistivity. What is rho? Rho is specific resistivity. If I find out the value of rho will be R into A by L. देखिए rho will be equal to R into A by L. If I take the length of the conductor 1 centimeter and the area of the cross section 1 centimeter square, then this will become 1, this will become 1. Resistance will be equal to rho. So how can we define rho, which is specific resistivity? Rho may be defined as the resistivity offered by a conductor when the length of the conductor is 1 centimeter and area of cross section is 1 centimeter square. हमने अगर L को 1 सेंटीमीटर ले लिया, लेंथ ऑफ द कंडक्टर 1 सेंटीमीटर ले लिया, एरिया ऑफ क्रॉस सेक्शन ले लिया 1 सेंटीमीटर स्क्वायर, देन रो, दैट इज स्पेसिफिक रेजिस्टिविटी, becomes equal to resistance. Thus, resistance which is offered by a conductor when length of the conductor is 1 centimeter and area of cross section is 1 centimeter square is said to be specific resistivity denoted by rho. Now let us find out the unit of rho. Rho will be equal to R into A by L. Rho will be equal to R is ohm, A हम लिख सकते हैं सेंटीमीटर स्क्वायर, and that is centimeter. 1 centimeter is removed. The unit of rho is ohm centimeter. The unit of rho will be ohm centimeter. I hope it is clear. This was specific resistivity. Now opposite of specific resistivity, जैसे हमने कहा रेजिस्टेंस का ऑपोजिट है कंडक्टेंस डिनोटेड बाय G, ऑपोजिट ऑफ रिवर्स ऑफ specific resistivity is equal to specific conductivity, and that specific conductivity is denoted by kappa, a small k, kappa. And how can we write down specific resistivity? Conductivity will be equal to 1 by rho. हमने क्या किया? That was R into L by A. Here it will become 1 by R into L by A. हमने उसका उल्टा कर दिया. जो आपकी specific resistivity थी, that was R into A by L. It will now become, conductivity will become 1 by R into L by A. L by A, remember L by A is the cell constant. किसी भी cell के लिए L by A will be always constant. Length divided by area of cross section, that is why it is called. So similarly, let us find out the unit of kappa. This will be 1 by R. 1 by R means 1 by ohm into centimeter divided by centimeter square. 1 by ohm can be written as ohm inverse, and the 1 centimeter will be left and centimeter inverse. 1 ohm inverse is equal to 1 Simon. 1 ohm inverse is equal to Simon. So we can write down Simon centimeter inverse. This is the unit for specific conductivity. Okay. Next very important topic which you have to study is what is molar conductivity. Molar conductivity, if you can see, I have denoted molar conductivity is denoted by lambda m. Molar conductivity is denoted by lambda m. If I simply define what is molar conductivity, if we have a container, an electrolytic cell, in which the two electrodes are 1 centimeter apart and the entire solution, the volume of the solution is V centimeter cube, we can say at V centimeter cube or 1000 ml, and we have dissolved the electrolyte equal to 1 mole. If you take an electrolytic cell in which the two electrodes are 1 centimeter apart and the volume of the solution is V centimeter cube, and the electrolyte solution has been formed by dissolving 1 mole of that electrolyte in 1 liter of solution or in V centimeter cube of solution, the conductivity which will be offered by such a solution, ऐसा solution जो भी conductivity कप्पा की वैल्यू ऑफर करेगा जब आपके दोनों इलेक्ट्रोड्स कितने होंगे, 1 सेंटीमीटर अपार्ट होंगे, जो पूरा सोल्यूशन है विल बी कॉन्सेंट्रेटेड, वॉल्यूम ऑफ द सोल्यूशन विल बी V centimeter cube, and we have dissolved 1 mole of an electrolyte in 1 liter of solution, या V centimeter cube of the solution. The conductivity which will be offered by such a solution, such an electrolytic cell, will be called lambda m. Lambda m is molar conductivity. Now how is molar conductivity related to specific conductivity? अभी हमने पढ़ा specific conductivity is kappa, 1 by R into L by A. So how is it related? Molar conductivity is given by kappa into 1000, this is V centimeter cube, वही volume है, divided by molarity. Kappa into 1000 divided by molarity. If you increase the dilution, सोल्यूशन का कॉन्सेंट्रेशन आप कम करोगे, डाइल्यूशन अगर बढ़ाओगे, पानी आप बढ़ाओगे, तो वैल्यू ऑफ कप्पा कम होता चला जाएगा, बिकॉज कप्पा डिपेंड्स ऑन, दैट इज स्पेसिफिक कंडक्टिविटी डिपेंड्स ऑन नंबर ऑफ आयंस पर क्यूबिक सेंटीमीटर. जब आप पानी बढ़ाओगे, डाइल्यूशन बढ़ाओगे, कॉन्सेंट्रेशन कम करोगे, तो नंबर ऑफ आयंस पर क्यूबिक सेंटीमीटर कम हो जाएंगे। लेकिन क्योंकि आप उसको वॉल्यूम से मल्टीप्लाई कर रहे हो, मोलर कंडक्टिविटी की वैल्यू डाइल्यूशन पे बढ़ेगी। टू थिंग्स आई हैव टोल्ड यू जस्ट नाउ। नंबर वन, kappa, what is the relationship between lambda m, that is molar conductivity, and specific conductivity? Molar conductivity is equal to specific conductivity into, ये 1000 क्या है, वही वॉल्यूम है, 20 सेंटीमीटर क्यूब डिवाइडेड बाई मोलारिटी। मोलारिटी आपको मालूम है क्योंकि हम 1 मोल ले रहे हैं, तो डिवाइडेड बाई मोलारिटी। नंबर वन इंपॉर्टेंट पॉइंट, द वैल्यू ऑफ स्पेसिफिक कंडक्टिविटी, specific conductivity, that is kappa, decreases with dilution because number of ions per cubic centimeter decreases. But molar conductivity of any solution increases with dilution. Why? Because you are multiplying it with volume. अब वॉल्यूम सोल्यूशन का बढ़ रहा है, ये कम हो रहा है लेकिन ये बढ़ रहा है, इसलिए मोलर कंडक्टिविटी, आप जैसे जैसे डाइल्यूशन बढ़ाएंगे मोलर कंडक्टिविटी ग्रेजुअली इंक्रीज होता रहेगा। दिस वॉज मोलर कंडक्टिविटी डिनोटेड बाई लैम्डा एम। Next topic which you have to study is equivalent conductivity. Same चीज़ है, denoted by lambda equivalent. It is denoted by lambda equivalent. हम क्या करें? We take an electrolytic cell in which the two electrodes are again 1 centimeter apart. Volume of the solution is V centimeter cube or 1000 ml, and I take 1 gram equivalent of a substance. Equivalent weight कैसे निकालते हैं? Once I had told you, for an acid it is molecular mass divided by number of displaceable H ions. For a base it is molecular mass divided by number of OH ions. For a salt it is molecular mass of the salt divided by charge carried by a cation. So for sulfuric acid, suppose मेरे पास sulfuric acid है, मैं उसका एक normal solution बनाना चाहती हूँ। एक normal solution means 1 gram equivalent of a substance of that electrolyte dissolved in 1 liter of solution. So I will, how much will I take sulfuric acid? The total mass of sulfuric acid is 98. So 98 divided by 2. Why did I take 2 here? 2 because there are 2 displaceable H ions. So if I take 49 grams of sulfuric acid and I dissolve it into 1 liter of solution, this is a 1 normal solution. So we were talking about lambda equivalent, that is equivalent conductivity. If I take an electrolytic cell in which the 2 electrodes are 1 centimeter apart, volume of the solution is V centimeter cube, and the electrolytic solution has been prepared by dissolving 1 gram equivalent of that electrolyte in 1000 ml or V centimeter cube of solution. Whatever conductivity has been offered by this solution, वहाँ हमने molarity लिया था in lambda m, here we take normality, will be told equivalent conductivity. Now how is equivalent conductivity related to specific conductivity? Equivalent conductivity is equal to kappa into 1000 upon normality. If you can see the page here very clearly, molarity is taken during lambda m and normality is taken during this. Let's find out the units of both the values. If we find out the unit, कप्पा की यूनिट हम लोगों ने फाइंड की थी साइमन सेंटीमीटर इनवर्स, वॉल्यूम को हम सेंटीमीटर क्यूब ले लेंगे डिवाइडेड बाय मोल. If you see this, it will be Simon centimeter square mole inverse. This is unit of molar conductivity. Similarly, if you take unit of specific equivalent conductivity, Simon centimeter inverse was the unit of kappa into centimeter cube divided by equivalent. So this will become Simon centimeter square equivalent inverse. These were two important topics. I'll continue the chapter in my next video.